Let's examine the costs associated with installing new electrical circuits. The first aspect is the material costs. A 20 amp ground fault circuit interrupter outlet is estimated at $15. A 20 amp breaker is estimated at $10. 12/2 Romex wire for a 50-foot run is estimated at $25. 14/2 Romex wire for an 80-foot run is estimated at $40. A 4-inch junction box is estimated at $5. Electrical tape, wire nuts, and staples are estimated at $10. The total material cost is therefore $105. Next, let's look at labor costs. Installing a 20 amp circuit with a 50-foot run is estimated to cost between $150 and $200. Installing a 15 amp home run with an 80-foot run and feeding 5 outlets is estimated to cost between $200 and $250. Drilling floor joist is estimated to cost between $50 and $100. The total labor costs range from $400 to $550. Now consider additional costs if no equipment grounding conductor or EG is present. A 15 amp ground fault circuit interrupter outlet is estimated at $20. A 5-port receptacle cover is estimated at $10. The total additional cost for no EGC is therefore $30. The revised total estimated cost without an equipment grounding conductor is between $535 and $685. The revised total estimated cost with an equipment grounding conductor is between $565 and $715. Considering a prior estimate for the work at $400 to $600, this estimate appears to be within a reasonable range, taking into account potential differences in material costs and labor rates depending on the location. The key components of a residential electrical system include service entrance, distribution panel, branch circuits, wiring methods, and grounding. The service entrance brings power from the utility to the building. It includes the service drop or lateral, meter, and service disconnect. The distribution panel, also known as a breaker panel, distributes electricity to individual circuits. It contains circuit breakers that protect each circuit from overcurrents. Branch circuits extend from the distribution panel to various outlets and fixtures throughout the building. They can be 15 amp, 20 amp, or 30 amp depending on the load they serve. Wiring methods commonly used in residential wiring include non-metallic sheath cable, also known as Romex, and electrical metallic tubing, also known as EMT. Grounding provides a path for fault current to return to the source, minimizing the risk of electric shock. It involves connecting all metal parts of the electrical system to a grounding electrode. Important National Electrical Code, or NEC, articles for residential wiring include Article 210, which covers branch circuits, Article 250, which covers grounding and bonding, and Article 310, which covers conductors for general wiring. Common wiring configurations include 120-volt circuits, used for lighting and small appliances, and 240-volt circuits, used for large appliances such as electric ranges and dryers. Ground fault circuit interrupters, or GFCIs, are required in areas where there is a risk of electric shock, such as bathrooms, kitchens, and outdoor locations. Arc fault circuit interrupters, or SIs, are required to protect against arc faults, which can cause fires. The NEC specifies the number and location of receptacles in various rooms. For example, receptacles must be placed so that no point along the wall is more than 6 feet from a receptacle. Lighting outlets are required in habitable rooms, bathrooms, and hallways. Smoke alarms are required in each sleeping room and on every level of the dwelling unit. Carbon monoxide alarms are required near sleeping areas. When adding new circuits, it is essential to calculate the load to ensure that the existing service can handle the additional demand. This involves adding up the wattage of all the devices that will be connected to the new circuits. When running new wiring, it is important to follow the NEC guidelines for wire size, conduit fill, and support. This ensures that the wiring is safe and reliable. When making connections, it is important to use the correct type of connectors and to tighten them properly. Loose connections can cause overheating and fires. When working with electricity, it is important to follow all safety precautions, including turning off the power at the breaker, wearing appropriate personal protective equipment, and using insulated tools. Here is a further breakdown of the topics discussed. Firstly, circuit breakers are overcurrent protection devices designed to protect electrical circuits from damage caused by excess current from an overload or short circuit. When a fault is detected, the breaker trips, interrupting the circuit to prevent overheating and potential fire hazards. Secondly, Romex, or non-metallic sheathed cable, is a type of electrical wiring commonly used in residential buildings. It consists of 2 or more insulated conductors enclosed in a non-metallic outer sheath. Romex is relatively inexpensive and easy to install, making it a popular choice for branch circuits. Thirdly, a ground fault circuit interrupter, or GFCI, is a safety device that protects against electric shock. It monitors the current flowing in a circuit and quickly interrupts the power if it detects a ground fault, which occurs when current leaks to ground. GFCIs are required in areas where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor locations. Next, the equipment grounding conductor, or EG, is a conductor that connects the metal parts of an electrical system to ground. It provides a low impedance path for fault current to return to the source, minimizing the risk of electric shock. The EGC is typically a green or bare copper wire. Electrical metallic tubing, or INT, is a type of rigid metal conduit used to protect electrical wiring. It is commonly used in commercial and industrial buildings, as well as in some residential applications. EMT provides excellent protection against physical damage and is easy to install. The National Electrical Code, or NEC, is a set of standards for the safe installation of electrical wiring and equipment. It is updated every 3 years and is adopted by many jurisdictions as the basis for their electrical codes. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. Voltage drop is the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause lights to dim, motors to run slowly, and other equipment to malfunction. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. An arc fault circuit interrupter, or FSI, is a safety device that protects against arc faults, which are dangerous electrical discharges that can cause fires. FSIs detect arc faults by monitoring the current waveform and quickly interrupt the power if an arc fault is detected. They are required in many areas of the home, including bedrooms, living rooms, and dining rooms. Receptacle spacing is the distance between electrical receptacles along a wall. The NEC requires that receptacles be placed so that no point along the wall is more than 6 feet from a receptacle. This ensures that extension cords are not needed to reach most locations. A junction box is an enclosure used to protect electrical connections. It is typically made of metal or plastic and is required to be accessible. Junction boxes must be sized appropriately for the number and size of conductors they contain. Wire nuts are insulated connectors used to join 2 or more electrical wires together. They are color-coded to indicate the size and number of wires they can accommodate. Wire nuts must be installed properly to ensure a secure and reliable connection. Electrical tape is used to insulate electrical connections and to protect them from moisture and corrosion. It is typically made of vinyl or rubber and is available in a variety of colors. Electrical staples are used to secure Romex cable to studs and joists. They must be installed properly to avoid damaging the cable. A service entrance is the point where electrical power enters a building. It includes the service drop or lateral, meter, and service disconnect. The service entrance must be sized appropriately for the load it will serve. A distribution panel, also known as a breaker panel, is a panel that distributes electricity to individual circuits. It contains circuit breakers that protect each circuit from overcurrents. The distribution panel must be sized appropriately for the number of circuits it will serve. A branch circuit is a circuit that extends from the distribution panel to various outlets and fixtures throughout the building. Branch circuits can be 15 amp, 20 amp, or 30 amp, depending on the load they serve. A feeder is a circuit that carries power from the service entrance to a distribution panel. Feeders are typically larger than branch circuits and are designed to carry more current. A grounding electrode is a conductor that is used to connect the electrical system to ground. It can be a ground rod, a metal water pipe, or a concrete encased electrode. The grounding electrode must be sized appropriately for the size of the service entrance. Bonding is the process of connecting all metal parts of the electrical system together to create a low impedance path for fault current to return to the source. Bonding helps to minimize the risk of electric shock. Overcurrent protection is the protection of electrical circuits from damage caused by excess current. Overcurrent protection devices include circuit breakers and fuses. Wiring methods are the methods used to install electrical wiring. Common wiring methods include Romex, EMT, and flexible metal conduit. Receptacles are electrical outlets that are used to plug in electrical devices. They are available in a variety of types, including standard receptacles, GFCI receptacles, and FSI receptacles. Lighting outlets are electrical outlets that are used to connect lighting fixtures. They are typically located on the ceiling or wall. Smoke alarms are devices that detect smoke and sound an alarm. They are required in each sleeping room and on every level of the dwelling unit. Carbon monoxide alarms are devices that detect carbon monoxide and sound an alarm. They are required near sleeping areas. Load calculation is the process of determining the amount of electrical power that a building will require. This is used to determine the size of the service entrance, distribution panel, and feeders. Wire size is the diameter of an electrical wire. The wire size must be appropriate for the amount of current it will carry. Conduit fill is the percentage of space inside a conduit that is occupied by conductors. The NEC limits the amount of conduit fill to prevent overheating. Support is the method used to secure electrical wiring to studs and joists. Wiring must be supported properly to prevent it from sagging or coming loose. Connections are the points where electrical wires are joined together. Connections must be made properly to ensure a secure and reliable connection. Safety precautions are the measures taken to protect workers from electrical shock and other hazards. When working with electricity, it is important to follow all safety precautions. Additional considerations for electrical work include local codes and permits. Always check with your local building department to determine the requirements for electrical work in your area. Hiring a qualified electrician is recommended for complex or potentially dangerous electrical work. A licensed electrician has the knowledge and experience to perform electrical work safely and correctly. Documentation of electrical work is important for future reference and for insurance purposes. Keep records of all electrical work performed, including permits, inspections, and receipts. This information can be helpful when selling the property or when making insurance claims. Regular electrical inspections are important to ensure that the electrical system is safe and functioning properly. Schedule regular inspections with a qualified electrician. Energy efficiency is an important consideration when designing and installing electrical systems. Use energy-efficient lighting, appliances, and other equipment to reduce energy consumption and save money. Future needs should be considered when planning electrical work. Anticipate future electrical needs and install additional circuits or capacity to accommodate them. Home automation is becoming increasingly popular. Consider incorporating home automation features into your electrical system, such as smart lighting, thermostats, and security systems. Surge protection is important to protect electronic devices from damage caused by power surges. Install surge protectors at the service entrance and at individual outlets. Power quality is the stability and reliability of electrical power. Poor power quality can damage electronic devices. Consider installing power conditioning equipment to improve power quality. Renewable energy sources, such as solar panels and wind turbines, are becoming increasingly popular. Consider incorporating renewable energy sources into your electrical system to reduce your reliance on fossil fuels. Electrical safety is paramount. Always prioritize safety when working with electricity. If you are not comfortable performing electrical work yourself, hire a qualified electrician. Continuous learning is essential for staying up to date with the latest electrical codes and technologies. Attend training courses and read industry publications to stay informed. This narration has covered a wide range of topics related to residential electrical systems, from basic components and wiring methods to safety precautions and future trends. By understanding these concepts, it is possible to make informed decisions about electrical work and to ensure that electrical systems are safe, reliable, and efficient. Remember that working with electricity can be dangerous, and it is always best to consult with a qualified electrician if you have any questions or concerns. Furthermore, specific to the context of the initial question, the presence or absence of an equipment grounding conductor or EG significantly impacts the approach to wiring and safety. Without an EGC, relying on ground fault circuit interrupters, or GFCIs, becomes crucial for protecting against electrical shock. GFCIs detect imbalances in current flow, quickly cutting off power when a fault is detected, preventing potentially fatal shocks. When an EGC is present, it provides a low impedance path for fault current to return to the source, tripping the circuit breaker and energizing the circuit. In older homes, it's not uncommon to find circuits without an EGC, especially in older wiring methods. In such cases, replacing the wiring with modern cable that includes an EGC is the ideal solution, although it can be more involved and costly. Another option is to install GFCI protection at the first receptacle on the circuit, which protects all downstream receptacles. This is a common practice when rewiring is not feasible. When adding new circuits, always ensure that the wiring method includes an EGC. This is a fundamental safety requirement in modern electrical codes. The size of the EGC is also important and must be sized according to the size of the circuit conductors, as specified in the NEC. When drilling floor joists for new wiring, it's essential to follow proper techniques to avoid weakening the joists. Drill holes in the center of the joist and avoid drilling near the edges. Use appropriate sized drill bits to minimize the impact on the joist's structural integrity. Also, be mindful of other utilities that may be running through the joists, such as plumbing and gas lines. When working with existing wiring, carefully inspect it for any signs of damage or deterioration. Old wiring can become brittle and cracked, posing a safety hazard. If you find any damaged wiring, replace it immediately. When making connections, use appropriate connectors and ensure they are properly tightened. Loose connections can cause overheating and arcing, which can lead to fires. Always turn off the power before working on any electrical circuit. This is the most important safety precaution you can take. Use a voltage tester to verify that the power is off before touching any wires. Wear appropriate personal protective equipment, or PPE, such as insulated gloves and safety glasses. This will help protect you from electrical shock and other hazards. If you are not comfortable working with electricity, hire a qualified electrician. Electrical work can be dangerous, and it's always best to leave it to the professionals if you are not experienced. Finally, remember to consult the NEC in your local electrical codes for specific requirements in your area. Electrical codes are constantly evolving, and it's important to stay up to date with the latest regulations.